Good day everybody. We are expected to integrate secant raised to the power of 5x dx without using the reduction formula. So without this aid, we are going to get the solution for this. So foremost, let me take I suffix 5 is equal to this. Okay, probably what I can do is I can, instead of saying I suffix 5, I will just state it as I, right? We don't need to have any I suffix 5. So next step is I'm going to rewrite this as secant raised to the power of 3x times secant squared x dx. Now we will be employing integration by parts. Let u be equal to secant raised to the power of x with a cube there, secant raised to the power of 3x. So you differentiate this, you get 3 times secant raised to the power of 3 minus 1 x. Differentiation of secant x is secant x tan x times dx. So this is going to be 3 times of, you have a 2 there and you have a secant there. So this is going to be secant raised to the power of 3x times tan x times dx. This is my du. So now let us deal with the dv. dv is secant squared x dx. So we integrate dv, we get v. Integral of secant squared x is tan x. Now the integration by parts formula is uv negative integral v du. My u is secant raised to the power of 3x. My v is tan x. On the left we have I, followed by negative integral v is tan x. My du is 3 times secant raised to the power of 3x times tan x times dx. I can rewrite this as secant raised to the power of 3x times tan x negative 3 times, this 3 is taken out. Tan x multiplied with tan x will give you tan squared x. So this is secant raised to the power of 3x times tan squared x times dx. So this is secant raised to the power of 3x times tan x negative 3 times integral secant raised to the power of 3x. I'm going to write tan squared x as secant squared x negative 1. This is perfectly possible because secant squared x negative tan squared x is equal to 1. So you move this tan squared x to the other side and you bring this 1 here. That's why you are getting secant squared x negative 1 is equal to tan squared x followed by a dx there. Now you product multiply everything. So this is going to be secant raised to the power of 3x times tan x negative 3 times of integral secant cubed x times secant squared x, that is secant raised to the power of 5x times dx, negative negative positive 3 times secant squared x secant cubed x times dx. Okay, now this could be moved over here, and when you move over here you already have what you got secant raised to the power of 5x dx. So you add up these two, you get 4 times integral secant raised to the power of 5x dx is equal to secant cubed x times tan x followed by positive 3 times of secant cubed x times dx. Now we have to integrate this. So let me consider integral secant cubed x dx, which is equal to secant x times secant squared x dx. I am utilizing integration by parts. So u is equal to secant x and dv is equal to secant squared x dx. So you integrate this, you get integral of secant squared x is tan x. Differentiation of secant x is secant x tan x times dx. So the formula is uv negative integral v du. On the left you are actually trying to integrate secant raised to the power of 3x dx, isn't it? So this is equal to u is secant x, my v is tan x followed by integral v du tan x, my du is secant x tan x. So this is secant x multiplied with tan x times the dx. So what I would do is we'll have to move to the next page. So this is integral secant cubed x dx, secant x tan x secant x tan x negative integral, you have secant x and 2 tan x are there, so it's going to be tan squared x dx. So this is equal to secant x tan x. I'm going to write tan x as secant squared x negative 1 times dx. So this is equal to secant x tan x. Secant x times secant squared x is secant cubed x dx, negative positive integral secant x times dx. Now already you have secant cubed x dx. So you move this to the other end, you have integral secant cubed x dx, positive integral secant cubed x dx is equal to secant x tan x, positive integral secant x dx. So you add these two, you get 2 times integral secant cubed x dx is equal to secant x tan x, positive integral of secant x is ln modulus secant x positive tan x. So therefore secant cubed x dx is equal to half times secant x tan x positive half times ln modulus secant x positive tan x. Okay, so this is what you've got. Now this is for secant cubed x. So what you have to do, you have to take that value and substitute here. If I were to take this as 2, so therefore 2 can be rewritten as integral secant cubed x is equal to secant to the power of 3x times tan x. Right. Now one important point here is this is actually 4 is here. So I have to take this as 2. Okay, my 2 will be this. Okay, so 4 times secant to the power of 5x dx is equal to secant to the power of 5x dx is equal to secant cubed x tan x negative, it's positive 3 times integral secant cubed x dx. This is what you have. Okay, let me show you that. So this is a system we are dealing with. This is secant cubed x tan x positive 3 times secant cubed x integration. So with the 4 there. But what is this? This is equal to secant cubed x tan x. I want to bring this 4 down. Positive, if I bring this 4 down, it's 3 over 4 off. This entire component you have to place. So it's half times secant x tan x positive 1 over 2 times the ln modulus secant x plus tan x. Okay, so this is equal to secant cubed x tan x divided by 4, positive 3, 4 times 2 is 8, 8 times secant x tan x positive 3 over 4 times 1 over 2, that's 3 over 8 ln modulus secant x plus tan x plus arbitrary constancy. So this is the integration for integral secant raised to the power of 5x dx without using reduction formula. Thank you everybody. Please like, share, subscribe.